Hello everyone. Today let's solve the problem number 18 for sum. So what the question states here, we are given an array nums of integers. See here, we are given an array of nums of integers. We have to find all the unique quadruples. We have to find all the unique quadruples. The last sum, we were asked to find the triplets whose sum will be equal to 0. Right. So this problem, what we are doing, we have been given an array nums of integers. We need to find all the quadruplets. Sorry, not quadruples. So we need to find all the quadruplets such that a plus b plus c plus d equals target. So sum of the four numbers should lead to target. Right. So here in this case, the sum of four numbers has to lead to 0. Here in this case, the sum of the four numbers has lead to the 8, target 8. So I hope this is clear. And they have mentioned all the indices are different. So given an array nums of integers, we have to find all the quadruplets such that a plus b plus c plus d equals target, and all the indices are different. All the indices must be different. We cannot use the same number twice, right? So we need to list the list of quadruplets in any order. We need to return the list of quadruplets in any order. So each quadruplet must be unique. They have strictly mentioned here each quadruplet must be unique and no duplicates are allowed. So this is very important. No duplicates are allowed and each quadruplet must be unique, right? So I hope the question part is completely clear, right? So we can return the list of quadruplets in any order they are mentioned in the question, right? And a plus b plus c plus d has to be equal to target. So we have already discussed the example as well. Here in this case, um, the four numbers has led to the target 0. Here also we have to consider four numbers that lead to the target. So let me come here. So just give me a second. Here, let's see this one. They have mentioned -2, -1, 1 and 2. See here, -2, -1, this one and 2. So basically 2 and -2 will give us 0, -1 and 1 will give us 0. So quite obviously target 0. So this will lead to 0. This is fine. And -2, 0, 0, 2. So -2, -2, 0. And other two numbers we have is 0. So this also works. And this one, -1, 0, 0, 1. So basically -1, 1, 0, 0, 0. The four numbers, this will lead to 0 as well. So these are the quadruplets that we need to consider and we need to return in the form of output. This is fine. Let's come to the second example here. We have 222 and 22, which has to give us the target 8. Basically we have to consider four numbers, right? So there is only one quadruplet that will yield to the target value, nothing but a 2222. That's what we need to return in the form of output, right? So I hope this part is completely clear. They have given us wonderful examples just for the sake of understanding, right? So I hope the question part is completely clear. Let's quickly discuss the approach followed by complexities and then let's write the code, right? So here approach, first thing is as usual, similar to the previous problem, this one, what do you call three sum, in the four sum also, what we will do first, we will sort the array. We will sort the array. When we sort the array, we get -2, -1, 0, 0, 1 comma 2, right? So we do this one. Sorting helps in this one by to make use of the two pointers. First thing, before this, we'll be going with the two pointer approach, man. Just keep this in mind. We will be going with a two pointer approach, right? So this is fine. So first step here is we will sort. When we sort, we will get this value, right? We will fix the first number, nothing but I equals -2. This one will be the first number. When we sort this one, we are sorting in the ascending order, right? So this one we will keep this one as first number and we will fix the second number, nothing but j. So I will be -2 and j will be -1 initially, right? So we will make use of the two pointers left and right to find the sum, right? We'll make use of the two pointers just to find the sum. So here what we will do, the left pointer will be this one and the right pointer will be at the end. The left pointer will be this one and the right pointer will be at the end. What we'll do, we'll check -2, -1, 0 and 2, right? 0 and 2. This one will be -3 plus 2, which will give us -1. This is not possible, right? So this is not possible. So we'll go with the this one next. This one we'll decrement this one. We'll consider this number -2, -1, 0, 1. No, this will also not give us 0. We can just sum up. So this will give us 2 basically, -2. So next we will go with considering 0, right? So this will also not give us 0. 2, -1, 0 and 0, right? So next we'll go with the next number, this one, -1. So first what we'll do, we'll consider -1, right? -1, we'll consider this one, -2, then -2, here this one, and here this one, what do we call? 0 and 0. So same thing goes with, we'll carry on the operations, right? So we'll carry on the same operations with the 2 pointers. What we get, so first triplet that we get here is 2, -1, 1 and 2, right? So 2, -1, 1 and 2. So this will lead us to the, or yield to the output 0. This will yield to the output 0. This triplet will consider along with these two triplets. I hope this part is completely clear. And one more thing, we will move the pointers based on the sum comparison with the target. Sum comparison with the target means it has to yield to the target 0. If it is not, then we'll be considering the this one. Right pointer will be decrementing. After checking all the things, we will again increment the left pointer, and we'll check with the other numbers that are left. Basically we'll carry on the operations until we find all the this one quadruplets whose sum is equivalent to the target. So here we will find duplicates for all four numbers to ensure unique results. So we have to remove duplicates, sorry, we have to remove duplicates for all the four numbers to ensure unique results. We quite obviously will not consider the again this one same result again, right? So we'll repeat for the other combinations as well. So I just showed this one for -2, -1, 1 and 2. So I can just check for the second this one quadruplet and the third quadruplet as well, right? So I just have to consider one number, two numbers, I and j. Then you have to check the left pointer will be next to that number and the right pointer will be right to that number, and you have to check by right number. Basically first you'll check with this, then you'll check with this, then you'll check with this. Next you'll go with the next number, you'll increment the left, and again the right again starts from end, you'll check the same number until all the unique quadruplets are found. In this case we have found three quadruplets, -2, -1, 1 and 2. This one, this I'm speaking of, right? These three. So just give me a second here. Yeah, these three quadruplets. So -2, -1, 1, 2, -2, 0, 0, 2, and -1, 0, 0, 1. This I'm speaking of, right? So I hope this part is completely clear. These are the three quadruplets that we find, right? So I hope the approach part is completely clear, easy to understand, right? So as we are completely familiar with the approach, let's discuss the complexities very quickly. So here what will be the time complexity and the space complexity? So the time complexity would be big of n cube for this. Previously we were considering the triplets, right? So we were considering the triplets. So the time complexity was, we have to run through two loops, right? So the time complexity would be big of n, this one, what do you call, n square, right? So we were considering first number and then we were going with the two pointers. Basically now we are considering two stagnant numbers initially, I and j, then we are playing with the two pointers. One is left and one will be one is left and one is right. So the left points to the next number to the j, and next element to the j, and the right points to the last element in the array, right? So here in this case, the time complexity would be big of n cube, right? Big of n cube at a time. It is big of n cube, right? And the space complexity, why it is big of n cube? Because we will be going with the two nested loops. While we write the code, you will understand this crystal clear, I bet it. So we'll be making use of the two nested loops, and we'll be making use of the two pointers within the two nested loops. We'll be making use of the two pointers inside. So this will lead us to the cubic time in worst case. So the time complexity would be quite obviously big of n cube, right? So this will be the time complexity. And what will be the space complexity? Space complexity would be big of 1. Why it is big of 1? Because we are making we are making use of only pointers and indices, right? So in this case, the space complexity would be big O of 1. So the time complexity would be big O of n cube for the code that we'll be writing in the future, and the space complexity would be big O of 1. I hope the complexities part along with the approach is completely clear. Now, as we are completely familiar with the approach and this one, what do I call complexities, we are good to write the code. Let's start writing the code. So accordingly with the approach, we have to store the final result list. So let's make use of the list here. List, this will be list of integer. List of integers will be making use of, right? So here this has to be capital I. This is fine. And this has to be result. So this will be new array list. This is fair. This is fine. So here, this is nothing but the final result list. This is fine. This is fair. Next step, we have to sort, right? So in the three sum also, in the previous sum also, we did the same thing. First, we need to sort. Sorting helps in using the two pointers basically. Sorting helps in using the two pointers basically. So I just go with arrays dot sort. If you still didn't understand the approach, I insist you to dry run the code. I insist you to dry run the code or dry run the example, right? So dry run the example accordingly with the approach discussed, right? So I have showed for the first triplet how we got. I just said we have to carry on these steps. You will get these three triplets for this particular problem. You just if you just want to know how we got this output at any cost, you can just dry run accordingly with the approach that I have mentioned, or after writing the code you can just dry run the code as well accordingly with the code that we have written. Both you can do, that's your choice, right? So I insist you to go with do the dry run accordingly with the approach because it helps you in the interview. You cannot just dry run the code after writing the code and dry run the example after writing the code and show it, right? So it's better to go with the approach, dry run the example, this one that they have given, and then let's then write the code. It will help you for writing the code basically, right? So it will help you in the interviews as well. So this is one thing. And arrays dot sort, we have to sort this one in the ascending order. Let's pass the nums here. So we are sorting to use the two pointer approach, and we are skipping the duplicates here. So the next step here is int n equals nums dot length. So we'll be making use of the variable n, this one nums dot length, so many times. So let me assign this one to the nums dot length. So this is fine. So as I've said, we'll be making use of the two for loops, right? So we have to fix the first number and we have to fix the second number as well. We need to fix the first number and we have to skip the duplicate first number. We need to fix the second number and we have to skip the duplicates for second number, right? Before initializing the two pointers. These two steps we have to do. So let's fix the first number. Let's make use of the for loop. So this will be int I equals 0, I less than n minus 3, and let's increment the I. This is fine. Within the for loop, what we'll do, we'll skip the duplicates. Duplicate first number means if I is greater than 0 and iterated value of the nums equals nums. So sorry, we have to go with the double equals Java, right? So just give me a second. Nums of I minus 1. This is fine. Let's do one thing. Let me give the keyword. Let me make use of the keyword continue here. So the next step is we'll make use of the one more for loop. We are going with the nested loops here, right? So we have discussed this one already during the this one. What do you call complexities while discussing the space complexity basically, right? So not space complexity, time complexity basically. So this is fine. We have to fix the second number, means I would have copied the same first loop. So this is fine. So and made the necessary change. This is fine. Let me type here j equals I plus 1, j less than n minus 2, and this has to be, we have to increment the j. So within this for loop, after fixing the second number, we have to skip the duplicate second number. Means if j greater than I plus 1 and this one nums of j, if it is equal to nums of, quite obviously, j plus sorry, j minus 1. Sorry, I got confused. Yeah, j minus 1. So then we have to skip uh, duplicate second number, right? We have to skip the duplicate of the second number. So this one, for skipping, I'll just make use of the continue keyword again here. So this is fine. So yeah, after these two steps, obviously we have to initialize the two pointers. So I'll just go with int left equals uh, j plus 1 and right equals n minus 1. This is fine. So these things are fine. So we are going with a 2 point approach. So basically left pointer has to be smaller than the right. So let me go with the while loop here. Within the while loop, what shall we do? We have to make so let's make use of the long here. So we have to deal with a large number. So let's make use of the long here, just to avoid the integer overflow. So I'll just go with long, the variable name sum equals, again within the parenthesis long, this will be nums of I plus nums of j plus nums of left. This one will be plus nums of right. Hope this part is completely clear. So we are just using the long to avoid the integer overflow here. So the next step here is, let's make use of the simple if condition here. Why so there are three conditions. We have to store the valid quadruplets, that is one condition, when sum equals target. So we have three conditions here, similar to the three sum. Here also we have only three conditions that we have to concentrate more on. Only three conditions. So one is when sum equals target, that is one thing. If the sum is lesser than target, that is one thing. And the third one is if sum is greater than target. So if sum equals target, then we have to return the quadruplet accordingly. For that one, we have to write the code. Same thing, whatever the thing that we discussed in the approach, that we need to articulate in the form of code, right? So when sum equals target, and when the sum is less than target, that is one condition. In that case, we have to move. We need a larger sum, and so we need to this one increment the left pointer. If sum is greater than target, then we need a smaller sum, and we need to decrement the right pointer. These three things we know. So let's articulate the same thing in the form of code now. First thing is if sum equals target. So here what we will do if the sum equals target. So let's go with result dot add. We need to add this one to the result. So I'll be making use of the add property here. This will be arrays dot as list. So as we have solved the three sum problem, this is solving the four sum problem will be quite obviously very easy, right? So this one will be nums of I, comma, nums of j, comma, nums of left, and the final one is nums of right. This is fine. I hope this part is completely clear. What we are doing here, we are just storing the valid quadruplets here. We are just storing the valid quadruplets here. So this part, I hope this is completely clear. So next we have to skip, we have to skip duplicate third number, right? We have to skip duplicate the third number, and we have to skip duplicate fourth number as well. Let's write this one using the while loop very quickly, right? So let's skip duplicate of the third number. So I can just write here left less than right, and nums of left, this one, if it is equal to nums of left plus 1, then we have to increment the left. So let me copy the same thing and make the necessary changes here for the for skipping a duplicate fourth number, right? So this one will be while left less than right, this remains same, and instead of nums of left, this will be nums of right. So this will be instead of nums of left plus 1, this one will be right minus 1. So this is fine, right minus 1. And instead of incrementing the left, what we'll do, we will decrement the right. So this will be will decrement the right. So this is fine. So we are just skipping the duplicate third number and we are skipping the duplicate fourth number. I hope this part is completely clear. Next, as usual, as we have solved the three sum, this will be incrementing the left and we have to decrement the right. So this is for the condition if sum equals target, right? So next other two conditions are left. So I'll just make use of the simple else if here. So this one, when the condition, this is the condition when sum is less than target. When sum is less than target, what we will do? We will increment the left pointer. Else, when sum is greater than the target, so this is the last this one condition, right? We can just write else here. Else, we will decrement the right. This will decrement the right. So here finally we need to return the result, right? We need to return the result. Let me come here. Let me return result. Need to return the result, right? So return the result means we have to return all the quadruplets that is equivalent to the target value. So here I have just given return result. So I have formatted the code. Let me hit the run button. So I hope this works. Let's see. So we have error here. Cannot find the symbol. Where is this? Line number 13. I should mention int here, right? So why didn't I mention int here? Here also I have mentioned int. Yeah, here I haven't mentioned the int. So let me hit the run button again. So yeah, now you can clearly see here the sample test cases got accepted. So let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct. Whatever the code that we have written works absolutely correct. So I hope the solution part is completely clear along with the complexities and the approach. Right. For now, this is it. Thanks for watching, guys.